Hello, I'm Mr. Ibrahim Makoga from Educare TZ. I'm teaching physics, and we are proceeding with our session on solving physics question on our topic that we have learned. And the level that we are going to solve is the topic of Form 1s, and we are proceeding with the topic of pressure. We are proceeding with the topic of pressure because we have already studied some topics, and you have to go and follow the session about the lecture session on the concept concerning the topic of pressure. Kwa hiyo nenda kapate maarifa kule, ili unapoenda kusolve uwe unajua nini una apply ile knowledge ambayo umejifunza. Usio una solve tu swali au unakalili swali lilivyo, kwa sababu unaweza kukuta swali wakati mwingine linabadilisha kidogo, lakini linataka concept ile ile afu ukashindwa kulijibu. So you have to follow that. In this session, we'll proceed with the question number 13. If you see, there are some question in the previous sessions, so you have to see. The question states that figure 1 shows a rectangular block of mass 80.2 kilogram, which is immersed in seawater of density 1100 kilogram meter cubic. What is the difference in pressure between the top and the bottom of the surface of the block? Given a rectangular block in the figure here, this is a figure that is stated in the question. This block is placed on a liquid on which top surface is in 2.00 meter depth, and the bottom surface is at 2.2 meter on the surface of that liquid. You are required to find the difference in pressure between the top surface and the bottom surface, between the top surface and the bottom surface. And if you check in our question, we have given the mass of the block. We have given the mass of the block is equal to 80.2 kilogram, and we have given also the density of the block, which is equal to 1100 kilogram meter cubic. Required to determine the difference in pressure. So use this figure to calculate. If you see this question is from the subtopic of pressure on liquid, you have to apply the concept of pressure on liquid in order to find the difference here. Here there is a solid block, but the pressure that is discussed here is about the pressure of liquid. So if we, because it's a pressure of liquid, you have to apply the pressure of liquid in order to know the pressure acting at the top of this block and the pressure acting at the bottom of this block. So that is about the question. And after then, let's see how the question was supposed to be answered, or how to solve this question. Say we have given the mass of the block is equal to 80.2 kilogram. Also, we have given the density of water, which is equal to 1100 kilogram meter cubic. We have given also height of top surface. Top surface of the block is at 2 meter, and height of the bottom surface is 2.2 meter. Gravitational acceleration is known, it is constant, g 10 meter per second square. Required difference in pressure. That is the question. After then, let's recall to which formula we can use. In order to get the result. We say from pressure in liquid is equal to density Hg. Density times 80 times the gravitational acceleration, that you get the pressure in liquid. The pressure in liquid depends on the density of the liquid, depth, on depth, and the pressure on liquid, because gravitational acceleration is constant. So that two things, density and the height, are what value the pressure of liquid. Then pressure of the top of surface block will be equal to P1 will be equal to density of water, height at the top surface times G. Density is equal to 1100 times 2 meter times 10 meter per second. If you divide well, you multiply well here, yeah, you will get that pressure on the top surface is equal to 22,000 Newton per meter square or Pascal. 22 Pascal Newton per meter square. Kwa hiyo ndo pressure ambayo ilikuwa na act kwenye top surface ya ile block. Kwenye top surface ya ile block maji yalikuwa na active pressure au liquid ile pale ilikuwa na active pressure ambayo ni 20,000 Newton per meter square au 20,000 Pascal. After then pressure on bottom, pressure chini sasa block ilikuwa na act kiasi gani? Pressure block chini pale sasa block ilikuwa katika depth ambayo ilikuwa ni 2.2 meter. Density ni ile ile inabakia constant na G. Then pressure will be equal to 1100 kg meter cubic times 2.2 meter times 10 meter per second square. Yeah, if you make well calculation here, you obtain that pressure acting at the bottom surface of the block is equal to 24,200. 24,200. On the top, it is 22,000 Newton meter square, but at the bottom, at the 24,200 Newton meter square. As you see, the bottom surface is acted by a larger pressure than on the top surface, as we have described that pressure depends on liquid. Pressure in liquid depend on depth, and it is directly proportional. So if you increase depth, you increase pressure. That is why we see here there is larger pressure than at the top. After then, to get difference in pressure, take P2 minus P1 to get the difference in pressure. Take the pressure at the bottom surface minus the pressure at the top surface. So after then, get 24,000 minus 24,200 minus 22,000, you get we get 2,200 Newton meter square. Kwa utapata 2,200. Kwa pressure difference ilikuwa ni 2,200 Newton per meter square. That was the pressure difference between the top surface and the bottom surface. Top surface and the bottom surface. So this was how the question was supposed to be answered. Hivyo ndio itakiwa tu mwanafunzi aweze kulijibu swali, bidi ujue tu kwamba hapo unachokiapply ni concept ya pressure in liquid na sio pressure in solid. Pale ni pana solid sawa, lakini itakiwa kwanza kufikiria kutumia pressure is equal to force over area, because here it is not applicable, itakuwa applied hapo. Ulipewa mass sawa, lakini mass ya pale haitakuja kutumika kwa sababu pressure ambayo inazungumziwa pale only ni pressure ya liquid. After then, let's see another question. Let us see another question in this session. The question that, what are the uses of the following devices? What are the uses of the following devices? Matumizi vifaa hivi hapa chini vina matumizi gani? Acha maanisha kama vifaa hivi chini vina matumizi gani? Unatumiaje vifaa hivi katika daily life? Kwamba first is manometer. What is the uses of manometer? What is the uses of Ayres apparatus or inverted tube? Ayres apparatus or inverted tube. So if you see inverted tube and Ayres apparatus, this is a single device. It is a name of single device. YouTube, YouTube. This is inverted tube. This is YouTube. And the number 4 is barometer. Barometer. What is the uses of barometer? So this is the question. Give the uses of manometer, uses of ears apparatus, uses of YouTube, and the uses of barometer. Part B of the question is that why a big elephant managed to walk comfortably in mud soil without sinking, while human being may sink easily. Why a big elephant does not sink on mud soil while a human sink. Binadamu ni mwepesi sana, ni mtu wa kawaida, ni mnyama ambaye ipo umbo la kawaida, lakini ukipita kwenye maji au ukipita kwenye udongo ule wa tope, yani kama tope, unazama. Lakini tembo na uzito wake wote ule na namna alivyo, anaweza kapita kwenye tope na asizame. Swali linauliza why? Kwa nini tembo anaweza kufanya hayo yote japokuwa yeye ni mkubwa sana na uzito wote alionao, lakini anapita kwenye tope na asizame? Lakini binadamu ukipita ni mwepesi, ni mdogo, unaomba dogo, lakini bado ukipita kwenye tope unazama. Swali linauliza kwa nini? Sasa tumia concept ya pressure kuelezea hii kitu, hii situation. Kwa nini hii situation inafanyaje inatokea? Kwa nini situation hii inatokea? After then, C said that draw a well-labeled diagram to demonstrate that liquid pressure depends on depth. Here a student is required to demonstrate how liquid can prove that liquid depends on depth. How we can prove that pressure in liquid depends on depth by using well labeled diagram, kwamba utumie well labeled diagram kuelezea kwamba liquid ina depend na depth. So that is a question, kwamba uelezee sasa tunavyosema kwamba ina depend na depth, kitu gani ambacho inafanya hata uweze ukaprove ukamwonyesha mtu kwamba hii ni sababu ambayo tunasema kwamba pressure ina depend na depth. By starting first uses manometer. We say manometer is used to measure the pressure of gas. So manometer is an instrument that is used to measure air pressure. This manometer is like a U-tube open at both ends, in which one end is connected to the gas supply. And one end is exposed to atmosphere. So you are measuring the pressure of gas by comparing with the pressure of atmospheric pressure. And inside the manometer there is a liquid, and the liquid that is used is mercury. So you'll see that when you connect a manometer on a supply of gas, one side of the limb will the liquid mercury will tend to be lowered in the one limb. If pressure of gas is lower in reservoir, then the liquid on the limb that is connected to the supply of gas will rise. But if the pressure at the atmospheric pressure is lower than the pressure of gas, you'll see that the limb that is exposed to atmosphere, the liquid is raised. So hii inapima atmospheric pressure kwa kuangalia uhusiano wakati wa inapima pressure ya gas kwa kupima na au kwa kuainisha na atmospheric pressure. Kwa hiyo kama pressure ya gesi inakuwa ni kubwa sana, kinachotokea ni kwamba liquid mercury ambayo ipo ndani ya ile tube, ile manometer, itapanda upande wa gesi kwenda kubalance pressure. Lakini kama pressure gesi ni kubwa kuliko atmospheric pressure, maana kile pressure gesi itapush mercury kidogo mpaka ikabalance pressure na atmosphere. Kuna kuta kwamba upande wa atmospheric pressure kule au upande wa tube ambayo ilikuwa exposed nje inakuwa faje, rise. That is about manometer. But here's a apparatus. This is a apparatus that is used to measure the density of miscible liquids. Here's a apparatus, hii inatumika kupima density ya miscible liquid ambazo zinachanganyika. Unatumia hii here's apparatus or called inverted tube. Inaitwa inverted tube. Hii ndio inatumika kupima hizo liquid of miscible liquid. Unajua miscible liquid are the liquid that mix completely, But YouTube is used to measure immiscible liquid. So YouTube is used to measure immiscible liquid. Hii hapa YouTube kama kawaida tumika kama U. Hii inatumika kupima density ya immiscible liquid. Zile liquid ambazo zichanganyikani, zile zinapimwa density yake kwa kutumia hii hapa inaitwa YouTube. So that is about YouTube. Here's the apparatus and the manometer. The last term was barometer. Barometer, we know that barometer is the instrument that is used to measure atmospheric pressure. And this barometer are divided into three. There is a simple barometer, there is a 14 barometer, and there is analog barometer. If you see simple barometer and the analog and the 14 barometer are the barometer that use mercury, but analog barometer does not use mercury. Kwa hiyo hizi barometer zinatumika kupima atmospheric pressure. So that is about. After then, let's see about the question, why elephant managed to walk on mud soil? You say a big elephant managed to walk on mud soil without sinking because of its legs having large area. Hence, its weight produces low pressure on the soil. So the pressure depends on the area of the substance, area of solid materials. Yeah. So we see why an elephant not sink. It does not sink because of large area on the legs, on its legs. So its leg has large area. That is why it produces small pressure. Its weight produces small pressure on the ground. That is why it does not sink. But human being produce large pressure on the mud soil. That is why you sink. Kwa nini tunazama sisi? Kwa sababu tuna produce large pressure compared to tembo. Tembo yenyewe ana mguu mpana sana pale, kwa hata akanyaga udongo, ule udongo hauwezi ukatitia kwa sababu area kubwa sana, anaproduce pressure yake ni ndogo sana pale chini, anaproduce pressure ndogo. After then, yeah, this question substitute wanasema kuna maswali mengi sana ambayo yanahusiana na kipengele hiki, but kitu cha kujua ni kwamba pressure is inverse proportion to area. So if a substance is made wider, it means that it is made to lower the pressure. But if the thing is made thinner, it means that it is made to increase pressure. Example, a knife. It is made to be thin in order to increase pressure, to make easy to cut substances. So that is why we make those knives to be sharp. Another was required to use by using a diagram. Show how liquid pressure depend on depth. So liquid pressure depends on depth because if you see here, this is hole 1, hole B, hole C. At hole 1, if a container is punched in 3 holes, you see that the hole 1 here will tend to lash out water slowly or at a small distance. The middle one will lash water at a somehow large distance, but the last one will lash out water far away. It means that this area, this hole is exerted by water in high pressure, in highest pressure than